Hello and welcome to another video. In this video we're going to be working on minimum bit flips to convert number. And in this one it says a bit flip of a number is choosing a bit in the binary representation of x and flipping it from a 0 to a 1 or a 1 to a 0. So for 7 you have 1, 1, 1, and you can choose any bit including leading zeros and flip it, and you can flip the first bit from the right to get 1, 1, 0 and so on to get a bunch of numbers. So given a start and a goal, return the minimum number of bit flips to convert start to the goal. And the other way of saying this is basically, given the binary representation of both of these numbers, how many of the bits are different? Because the differences are the ones you need to flip. So here they are in this first one. So this first bit is different, so you're going to need to flip this one. The second bit is also different. The third bit is the same, and the fourth bit is different, so you need 3. And then in 3 and 4, so here's 3 and 4. In 3 and 4, all the bits are different, so you need 3 as well. So there's kind of two main ways of doing it. One, you can compare bit by bit, but another way you could do it is, let's say we have two numbers like this. And we have another. Actually, let's maybe draw it in an array, it'd be easier. So we have some numbers. One is like this, 1, 1, 0, 0, maybe. And another one that's like this. Say 1, 0, 1, 0. So the other way you could get the differences is you can actually just XOR the numbers. Because when you XOR the numbers, the XOR of 0 and 0 is 0. So if they're the same, it will be 0. 1, 1 is 0. But if they're different, then you will get a 1. So if the two bits are different, you'll get a 1. So basically, if we XOR these two numbers, we will get 0, 1, 1, 0. And then all we have to do after that is just figure out how many 1 bits are in the resulting number. And from that, we can just keep getting the last bit, ANDing it with a 1, and we keep shifting it to the right. So basically we'll check, like, is this bit a 0? No, let's shift it to the right, which means get rid of the last bit. Is this a 0? Yes. Or sorry, the first one was a 0, so this doesn't matter. You basically look how many 1s you have. So that one was not a 1. This is a 1, this is a 1, this is a 0, so you have 2 1s, and then you just return 2. So basic, just count up the number of 1s in a number. And those are going to be the two steps. A XOR B, and then count 1 bits. And that's basically it. So let's do that. So let's first get our XOR number. So start XOR goal. Now we can just say while XOR is greater than 0. Let's keep adding these, so we'll have a result. And while this is the case, result plus equals. And so to check if the last bit is a 1, we could just say XOR and 1. So ANDing a number with a 1 will give you a 1 if the last bit's a 1, and will give you a 0 if it's a 0. Because basically what you're doing is, let's say our number is like this. We basically AND our number with this, so everything here will be 0, and the last bit will just check if it's a 1 or not. So this will give you 0, but if this was a 1, we would get a 1 here. So that's how you check there, and then we just shift our number to the right. And then we're done. So yeah, not much to this one. So XORing two numbers is typically log time because you have to XOR bit by bit. So it's going to be like O of the max, I guess, of start and goal. But this is basically 0 because, you know, let's say our number is 10 to the 9th. This might give you like 20 or 30 or something. So it's basically constant time. And then same thing, counting all the bits of a number is also log of the number because you're taking every bit and you're looking at it. So we'll just say it's this. But technically it would be like log of the actual number. And this is this. And yeah, I'm going to be all for this one. Not much for this one. So thanks for watching.